Hi, welcome to Brownfield module demonstration. My name is Naomi Liboke. My team members are Mipi Libelo, Flavia Chucho, Ntobi Sintanzi, and Mojani Sikutwanyan. I will be taking you through our project overview. This project involves the Brownfield development of an existing robot world code base to refactor the code to improve quality and add new functionalities. The project consists of three components, which are the world server, the robot client, as well as the robot world protocol. Under the world server, it is responsible for creating and managing the world environment, including all obstacles and any new elements we introduce. Listens on a network pod for incoming robot connections, handle receiving instructions from each robot, and updates the world based on the robot's actions, and send feedback to robots informing them of how their actions have affected the world. And then under the robot world, operate independently and connect to the world server over a network. Once connected, it launches a robot into the world, allows user to issue commands to robot via the network, updates all the robot's position as it receives commands, and learns about the world as it moves. And then under the robot world protocol, a common protocol that all teams must implement to ensure compatibility. And we also had to allow any client robot program to connect and interact with any team's world server on the same network. And lastly, we had the exact specifications of the protocol, which are detailed in the robot world protocol document, which all teams had to add. Documenting For documenting our project, we used GitLab. GitLab was an essential source file and tool for documenting and managing our project. When it comes to version control, Git helped us track changes to all our source files, including code, configuration files, Docker files, and Makefiles. It ensured that we are working with the correct version. GitLab CI/CD configuration played a vital role too. GitLab CI/CD configuration ensures that our project runs smoothly and we utilize the correct source files which were needed. And as you can see, there are files which are needed, such as the YML file, the Docker file, as well as the POM file and the README file. Now I am going to demonstrate how we protect source files from loss while updates are in progress and will make changes to one of the files. We can do so by performing the git pull command, and then after git pull, it will show that updates are already up to date, and then we can make changes to one of the files, and then after making changes, we can click get status, git add, commit, and then git push, and then we'll check the GitLab for the update. Okay, so this is what we'll do. Git pull, like I had already mentioned. And then it will view that it's already up to date. And now lastly, for section A, using Git as the version control tool to prevent source files from being updated simultaneously by two or more people while retrieving source files, we made use of backlogs where we'd assign issues and then have everyone on their respective tasks. Moving right along to section B, where we will touch on code and design conformance. For us to launch the robot, we will open the multi-threading. where our server is based. And then when you run the multi-threading server, you will need to enter port number, and then after you enter the port number, you will get all the commands that you can run, which run on the multi server. And then after, for you to be able to launch a robot in the world, you have to run client. And then after you run client, you have to enter localhost as the IP address for the server, followed by the port number, which is 1024, the one that we had initially entered in multi-threading. And then from there you'll get a welcome page. Then from there you will be able to launch a robot in the world, depending and then the depending on the type of robot which you want to launch. And then in this case we have launch Sniper R. And then for us to be able to check the concurrency between the two, we go back to multi-threading, where we will find that the robot has already been launched. So that is how we are able to see it, and then we will get the
Thank you so much, Naomi, for covering Section A and a portion of Section B for us. I'll be covering the remainder of Section B, which consists of questions 9 through to 14, and I'll also be covering a portion of Section C for us in a form of slides. To begin, we have our README file over here. And what our README file is all about is it gives a description as to what our program is all about, how it works, how to run certain things, and how to install certain things so that the user can have an amazing experience with our program. So what Robot World is a server-based multiplayer game that is played over the network by the connected user, and the user must be connected to the Robot World server in order to launch their preferred robot. So how this works is, firstly, you need to have your Robot World server up and running, and then the user will then have to run the client program, and they will be prompted to input their IP address and port number which the server is running. The user will then be required to launch the robot into the world. Options are given at the start, and once the robot is in the world launched, it is ready to make moves and any other commands, and the user does have the option to mid-game quit if they'd like. How are we going to run the server program? So we have a command here which the user can copy and paste into the terminal in order to run the server program. Alternatively, if you're using Maven like me, IntelliJ rather, you will go to the multi-threading class which is inside our server folder, and we'll right click on it and run it. We'll then be taken to the terminal where we'll be prompted to input a valid import number between the ranges of 1204 and 49151. I will import a port number of 1204. Rather, let me input a port number that is not within the range to see how this is handled. I input 123, and it tells me valid port numbers reserved for user server application with the port range that we have. Then I will put the valid port range that we have here, and will be entered into our server, telling us the server is up and running. And below we have a display help message box with available commands. We have the dump command, which gives us information about the world state. We have the help command, which displays the help message that we're looking at now. We have the robots command, which shows us the robots in the world and their states. We have the save command, which saves our current world state configuration. We have the restore command, which restores the configuration of the saved world. We have the purge robot command, which kills a robot and removes it from the game. And then we have the quit command, which is to close the server. So for demonstration purpose, we are going to type in robots and enter. And we see a list of all the robots in the world. And as you can see, there is no robots in the world because we haven't launched any. This then takes us into our client server program. We have a command which the user can copy and paste into the terminal to run the client's program server. Alternatively, if you're using IntelliJ like I am, you can go to this client folder and right click on the client class, run the client class, and we'll be taken into the client class's terminal. And in the client class terminal, we will be asked for an IP address to our local host, which is the IP address of our PC. I'll then input mine over here, which is 192.168.73.138. And I will then enter. And then I'll be asked for a port number. The port number that I've entered while running our multi-threading class is the same port number that I'll insert here, which is 1024. And I'll enter. And then we have our display of Robot World. Above you can see Robot World there, and then below it we have a list of our robots types, the shield health, the clip size, effective range, bullet damage. We have a sniper, a tank, a shooter, and general. And below that we have instructions in blue on how to launch our robot, an example of how to do so, and for more assistance we type in help to get access to all the available commands to use. And in this case we will type help and enter. And in our help we have a list of commands available in our help box, and we'll go through that later once we've launched our robot. Right now we're going to be focusing on the usage. So to launch a robot we need to insert launch, our robot type, and the name of our robot. As you can see in an example, we have launch sniper, sniper being the robot type, and Travis Scott being the robot name. So in this case I am going to launch a sniper as well, called Die Hard. And I will press enter, and it'll tell us that the robot is successfully launched, and I am currently at position 00. Now I have the option to enter actions to execute. This is where we go to our available commands. We have the forward N command, which moves forward by N units, N being the value or the number of spaces you want to move. We have execute. This is where we go to our available commands. We have the forward N command, which moves forward by N units, N being the value or the number of spaces you want to move. We have the back N move, which moves back by N units, the number of units we want to move back. We have the turn right command, we have the turn left command, we have the help command which displays this help message, we have the look command which examines our surroundings, we have the fire command to fire our weapon, we have the reload command to reload our weapon, we have the repair command to repair our equipment, we have the quit command to exit the program, and we have the state command to check the state of our robot. So let's move our robot forward by 10. It tells us that we have moved forward by 10 and we are now at position 010. I'm going to say forward by 100 now. It's going to tell us that our robot failed to move forward due to it not having enough space. We're then gonna forward 20 to see what it does, and it tells us we have moved forward and we are now at position 030. Let's say back 5, back 5, and we have moved back, and now we're at position 25. I'm going to say turn right, and we have turned right, and now we are facing the now earn direction. We are now going to type in state to see our robot state, and our robot state has been checked. Now when we go back to the multi-threading side, we are going to type in robots, and as we can see, there is no robots in the world because our robot has been removed from the world. Now I'm going to go back to the multi-threading side, and I'm going to type in robots, and it's going to tell us that we have a robot in the world, and it's robot Die Hard. It's a sniper. It's at position 00. It's facing north, shield 5, shots 2. Now I'm going to go back to the client side, and I'm going to tell my robot to move forward 10. It's going to tell me I have moved forward 10, and I am now at position 10. I am going back to the multi-threading side, and I'm going to type robots again. And it's going to update this information, letting us know that we're at position 10. As you can see, I have typed in fire. It tells me that I have fired, but I've missed a shot. And when we go back to multi-threading, I am going to type robots again. And it's going to tell me that I have a 1 shot left because I've used my shots. And my status is normal, so my robot is still healthy. Now, when it comes to installation, our installation instructions and everything else is in our make file over here, which we can see everything here. The commands we need to copy and paste into our command terminal. Uh, the requirements that we need, the version file we need in order to run the program, and how to compile it, how to build it, the tags, and the test. Now we will go to running. Before we go to running the test, let's talk about our code structure. Before we go about running our test, let's look at our code structure. So, as you can see, we have our code structure over here. We have a folder client, which has all our classes, which is client, invalid command, launch command, state command. We have our data folder, our interface folder, our message folder or our M folder, reference client folder, robot folder, server folder, which entails our multi-threading class, robot world server class, our server handler, our server runner. We have our web server folder, our world folder, and then we can go to our test. We have our acceptance test, which is the test as you can see all these ones over here. Then we have our regular test. So let's go and run our move acceptance test. And we're going to right click on it and we are going to run it. And as you can see, our acceptance test has passed. Then we'll go to our launch command test and we will run it. And as you can see, our test has passed. And that is it for our README file, our make file, our code structure, test cases, and how our program works and everything. And in terms of our code health and analyzing our code, that will be displayed on the slides to follow as we go on to close off section B. We have our code scene, which analyzed our code, and as you can see, our overall code health is very good. And now I'll be taking you through section C, which consists of questions 1 through to section section C focuses on database management system. So what is database management system? It is a software system used to store, retrieve, and run queries on data. A DBMS serves as an interface between an end user and a database, allowing users to create, read, update, and delete data in the database. Problems presented by database management issues is data redundancy, which occurs when the same data is stored in multiple locations, leading to increased storage cost and potential inconsistency. Data inconsistency, which arises when different versions of the same data exist, causing confusion errors. An example of this is if customer's address differs between the sales and shipping department. And then we have data security, which involves the risk of unauthorized access or breaches, compromising sensitive information. And finally, we have data integrity. And this ensures that data is accurate and reliable, and errors or unauthorized changes are prevented. Solution to data management problems. The solutions that we have over here is normalization, which is organizing data to reduce technology, solving data inconsistency, single source of truth. Centralized database ensures consistent data, and solving data security, we have access controls restrict data access to authorized users, and solving data integrity includes validation rules, ensuring data accuracy through predefined rules. Features of commercial database management systems. This covers the features and problem resolution. So we have data storage and management. The feature is centralized data repository, and the benefit produces redundancy and ensures consistency. Then we have transaction management, which the feature is AICD, automicity, consistency, isolation, durability properties. The benefits of this, it maintains data integrity during a transaction. Then we have data security. The feature is user authentication and authorization. The benefits of this is protecting data from unauthorized access. And we have backup and recovery, which is automated backup system. This ensures data is recovered in case of failures. Purpose of common DBMS features. Minimize redundancy and ensure data integrity, to speed up data retrieval process, to encapsulate business logic and improve performance, and to automatically enforce rules and data integrity. Characteristics of different database management system types. We have relational database. The characteristics is table-based structure, SQL for queries. Then we have no SQL DBMS. Characteristics is flexible schema suited for unstructured data. Then we have object-oriented DBMS, which characteristics are to store data in objects and support complex data types. And then we have hierarchical DBMS, which the characteristics is a tree-like structure, parent-child relationships. The example of the different types of database management structure in use, we have MySQL, PostgreSQL, we have MongoDB, we have IBM Information Management System in legacy system. Features and limitation of database management system end user tool is query builders, which is easy to create queries without SQL knowledge, complexity handling, limited ability to handle complexity. The use of DBMS end user tools. We have query builders, reporting tools, and data visualization tools. The use of these three tools are as follows. So for query builders, the use is to simplify the creation of data queries for non-technical users. Reporting tools are used to enable users to create custom reports and dashboard for decision making. And visualization tools are used to provide graphical representation of data trends and patterns. So my group and I, we used SQLite.
Good day, my name is Mojane and I will be taking over from my teammate. So, we will start with the objective for our database within the robot world's context, or brownfields, so to speak. Um, our database, or let me start off by saying we all know that computers are much faster at analyzing data and interpreting that data than humans are. But I still believe that we have the edge over these machines in that we are able to almost automatically save that information uh, quite persistently. And computers don't do this so well. If you think about it, computers spend half their time working with volatile memory, which means if you were to restart your computer, turn it off, or if you were to even close the execution of a program or stop the execution of a program, whatever data that was running within it will be lost forever unless implicitly or explicitly saved, rather. So, this is where our database in the context of robot worlds comes in. This database is meant to be able to save any worlds and restore those worlds along with their world sizes, their obstacles, and any sizes of the obstacles along with the positions of the obstacles. And upon so doing, allow us to be able to play within a world that was previously saved. We will now move on to the user requirements and how our program addresses it. The requirements are to save the world in a way where the user will be able to easily access it and understand exactly what is happening within the database itself. So, if we think about it, we have our world table here, and each of the worlds in this table has a name and a size, and along with that size, it has an ID. This ID is a unique identifier for each of these worlds, and you may use it as a primary key for each of these worlds. So, if we think about whether we are catering for the program's data needs, um, the world itself, the world's table, is linked to a saves table um, along with an obstacles table, and they are linked by a foreign key, the world ID, which appears in both the obstacles table and the saves table. In our obstacles table, we also have some positions of the obstacles along with the sizes of the obstacles. Note that each obstacle is linked to a particular world or its respective world by a world ID, but each of them has their own unique identifying ID. And this one is used to pretty much single out any given obstacle we may want to be able to single out. Now, if we can check on another table, we can go into the worlds table. And in the worlds table, we will see, as we have previously discussed, that there's a world name. There is, for example, world with a E, world WTC, world, and world 1, each of which also have their own unique identifier, which is the ID. And this ID specifically for the world is used in the other two tables in order to pretty much relate all of the information or data in our database, um, along with the sizes and everything else. So if we can go to our saves table, we will notice that each save has an ID along with a world ID. So basically the whole premise of this table is to encapsulate all of the information of a world, including the name, its obstacles, and everything about the world within a neat little package that we can call a save. Each of which we can differentiate using the save ID, but it's just the ID in the table. Yes, so using that we will be able to access pretty much any world we like. But with that said, it is much more convenient on the eyes if you're able to see the name, the size, and pretty much all of the obstacles in real time. So we will move on back to our obstacles table. In our obstacles table, we can go over some of the columns there. We have our ID, the world ID, the top left X, the top left Y, and the size. Now, each of these obstacles, despite having a unique size and position, as we can see there, is linked to a world by the world ID. And this is pretty much our foreign key in this context. It is the key that we are using to be able to differentiate between the obstacles that belong to different worlds. As you can see, the world ID, there is 2, and the name of the world is world 1 with a size of 300. And where the world is ID is 3, world WTC is the name, and the size is still 300. But if you would like to change the size, you can do so. Um, with that said, it's easy to be able to look at this list of obstacles and be confused. But if you link each of them to their respective world, you will be able to see that this information is pretty much easy to decipher, nothing too complicated. On the left, we have our auto incrementing primary key, and as we have previously discussed, this on the right is our world ID. So in terms of us being able to show pretty much if we wrote any SQL statements, we will have to move to the save game and the restore game classes. Now, upon reaching here, you will notice that there are some strings there, and those strings are mainly used by us to be able to send queries and pretty much interact with the database itself. So we are using the JDBC to be able to access our database and interact with it. So if you don't have a save game file by default, which is the database, if you don't have a database, this program will create it for you. The save game class will create the database for you, and pretty much that is where all of your data will be inputted, and that is where we will update all of the world attributes and so forth and so forth. If you can look there at our statements, we have a create saves table statement, we have a create worlds table statement, and as well as a create obstacles world table statement, each of which create tables while outlining the parameters for creating each of them. For example, we create a world with an ID integer, which will not be null, so it must not be an empty column, and this will be our primary key for that table. And we have a world name as well as a world size, which shall not be null, which shall not be null. If we take a look at the next topic in question, we are using SQL code that is pretty much understandable, because if we move to the restore game class, you can see here that we are using statements that pretty much spell themselves out. You don't really need a rocket science degree to understand what these statements are saying. For example, we have a select count all from worlds. So select everything from worlds where the world name is equal to a specified variable. If you look down there, that variable is the world name, this dot world name. So if you give any name that will be put or passed into our constructor for this class, it will take that name and then substitute it into the SQL statement that is named check world exist query. And that is basically just to check if the world you're trying to restore actually exists, so you don't restore a world that doesn't exist. The same can be said on our save game side. We used this similar statement, but we also used an insert into worlds, which basically just inserts any information that you specify into the columns.
Thank you, Mojan. So I'll be carrying on from where my team member left off. First of all, my name is Mtobi Sintanzi, and I'll be doing section D, evaluating SQL implementation and data management in web applications. So first of all, I would like to go back to my code. So to demonstrate functionality that makes the SQL code understandable, I'd like to show you where the code is actually placed. The code rests in the class which is our create obstacles, create saves, create roles tables. Then we also have our restore game and save game. So the create classes, the ones that's what create, what they do is actually create the different classes. They connect to the database, and then you will have our create table, which is saves. Um, we over here we create the world table, and then we also have a class for saving for worlds. Excuse me. So that is where the code lies for creating the different tables, and then we also have our restore, which is the SQL, which is where the SQL which actually pulls data from from the database and then shows it to the user. And over here we have save, which actually saves the data to the data table. So to demonstrate the necessity of the table joins, what I'll have to do, I'll actually just give you guys a test run of the code. So let me just start the server up. Okay, so now server, I'll start the server and I'll choose port 4500. So there we go, our server is up and running. First of all, before I say, I usually like to see what the world looks like. And then now that I have an idea of my world, how many obstacles I have, I can easily run the save command, which is save. I would like to call my world um, so maybe until 2. There you go. The world has been saved. So I'll just stop the server. So now I'll go over to my database and then I will look into the worlds I have. Refresh. There you have it in total. So in total over here to show you the different joins in our tables, you'll notice that in total the ID for total is actually 2 also. So then if you look at the obstacles, I have to just scroll down, go to world ID 2. Once I get there, I'll notice that all the obstacles which belong to world 2, which was Tor world, are now saved here. And then just to see my saves, I know that I have 2 saves, which basically identified by the IDs. So that is my demonstration of the joins and also showing the functionality of the program. Okay. Um, I will now show you the different methods of accessing the data in the program. As I actually showed earlier on, but now I'll dive deep into it. So to save stuff, our command, which is create save game, selects everything from the world, and then the ID will be passed on as a parameter uh, over here. The oh, excuse me, over here, and then once we pass that on as a parameter, it's saved into the world. Um, it is saved into the world. Along then later on, as you saw in my code, I actually got a confirmation message. Then to retrieve the data, we have methods such as restore game. So what restore game does, it takes in a parameter which is the world name. So you need to call the world name which you saved the data as in order to call that previous world again. Okay. And then to also showcase data sharing, this database which I showed you can be used by anyone, and if you just take the database and plug it into a different world, as long as if you can read, as long as if you have the correct commands to read our server, you will always have access to what we have and the data inside our database. So now I'll be going on to demonstrate technologies that link databases and websites. So first, I'll go into our web server file. This is where we actually start our server, but then where the code actually lies is in here. So in this class, the server class, we are using Javelin to create our API. Even although you can see we have commented some parts out, our server is not running to 100% completion, but it is our API is there, and we have tried implementing it. In terms of the backend proprietary applications, we since the API is not necessarily running, we cannot really show you that part of the application. And then the code, yes, unfortunately, there is some commented parts out, but it's just only the section. Otherwise, everything else is not commented out. It's clean code. We made sure to follow all the standards of coding. Yes. So just to show you the restoring of the world, I'll run the server again, and then this time I'll run restore. So underscore two, and then I get the world I previously had. So unfortunately, I did not check the positions, but if you were to recall or rewind the video, you'll notice that these obstacles are the same obstacles I had in the previous section. Therefore, showing that the database, we have retrieved the information we wanted from the database. Okay, so next up, I'll be leading you guys into section E, which is evaluating test execution and database verification in software testing. So first of all, before we get into the code, I want to first share our issue boards. So basically, to make sure to make sure we actually stay on track in terms of identifying our test plan, we had an issue board which we kept going over as a team, updating. Yeah. So how it went, we had a backlog, and as we kept working on the project, we move an item from one place to the next until eventually we close the item. And then now for the code. So in terms of testing, we first of all we got our reference servers over here, and we use those to actually create our acceptance test. So using our acceptance tests, now we had an idea of, for example, the reference server gave us an example of what our server is supposed to look like and what it's supposed to give. So the different tests were tested firstly the on the reference server, and from there on, we had to modify our server to work with the necessary changes in the acceptance test. So that is it. In terms of deviations, we didn't. Our backlog actually kept us from deviating. So this guy actually helped us a lot. Like it helped us a lot in terms of deviating from the project. Yeah. So that is it for my part. Now I'll just throw it over to my teammate Benny.
Hi, I'm Benny, and I'm going to be walking you through how we approached our documentation in this project. So, initially, when we received the code base, it was documented. However, there was a lot of inconsistency, and in most classes, there was little to no documentation, and it gave us a huge headache in terms of figuring out what each class does and just figuring out how to navigate around the code base. It gave us a bit of a huge nightmare, but we did go about that. And we did decide that as far as our work goes, we will implement a better approach towards documentation because we actually realized how harmful it is to actually poorly document your code. So we took a different approach towards it, and we first started by creating a wiki on our GitLab, which which outlines the project overview. It also goes about how how the world server works, what it does, the robot client, what it does, and how it works as well, and how they communicate. And we've also outlined supported commands because this wiki could be used as a user guide as well to outline what the actual end user what they could do with it within the software program. For example, we have our commands here, and obviously sometimes things don't go as planned, so we accounted for troubleshooting as well to give them an idea of what's actually going wrong in terms of the errors they're getting. And to install that, we have also went about installing the program, so we added that to our wiki as well, which accounts for the end user as well as a guide. Not almost finally, we have licensing, which basically gives whoever is watching this an idea of who owns the software program and what they're allowed to do and not allowed to. And at the end, we have our credits for the for the project as far as Brownfields goes. We did not account for the people who first developed the program from inception. And as far as in the actual repository, we actually have a README which outlines how to actually run the command, how to actually run the program and how it works. And it's not really as detailed as the wiki. And yeah. So in terms of documenting the actual code, we actually made sure that as far as we document almost everything. So one thing we could not document here is the actual fields because we noticed that we have way too many variables and it would just make the workspace way too cluttered. But we do have our class level comments and constructor comments, and overall we just have comments for we have documentation for almost every single thing uh besides for our variables because there's too many of them. And we also have parameters and what the function returns if it does return. For example, this function does return something, so it gives the type of what it returns and what it actually returns. So we did not implement a lot of line level uh, comments because it does make the the workspace cluttered. However, on launch command, we did have a case where it was really, really necessary because for the whoever's going to be working on this code in future for future references, we did account for the documentation in this instance, whereby it would make better sense for us to, because of how we're handling our our errors here, we decided to actually go about line level documentation because there's not really much description to all of this, because it would be redundant for whoever is working on the code to go look at the function manually and come back to looking at this. So we just decided to go with line level to account for everything. And overall, we made sure that we documented everything in a precise and coherent manner in order for optimal workflow.